All right, good morning and welcome to week 9 of CNET58. This morning, we're going to take a look at what is Hyper-V, since that's going to be the platform of our virtual system for the next half of the class. So we'll do that, and then today's lab will be basically setting up our virtual environment on Hyper-V. So whereas we were on VMware ESXi the last 8 weeks, we'll now transition to Hyper-V. All right. So I'm gonna share my screen, and here. All right. So hopefully you can see that. Let me turn off my ringer on my phone. There we go. All right, so good morning and welcome to CNET58. And again, we're going to kind of, if you want to use the term, shift gears, change lanes, change the page, whatever you want to, whatever adage you want to use there. But we're going to switch over to Hyper-V as the foundation, the type 1 hypervisor for the rest of this course. So, and I'd like to do it this way because the two main technologies that you're going to work with as a server technologist is with VMware. You're going to see VMware in the bigger enterprises for sure. And then I know you're going to run into Hyper-V in the small to medium-sized businesses. So this will just give you the opportunity to experience both of those. All right. So first thing I want to talk about is the midterm exam, and the lab midterm. The average score on the midterm exam was an 83%, which is really good. You know, anytime you can have a class average above a B, that means the test was a good test. And then the midterm lab, the average was 71%. And the reason that score is a little bit lower than I'd like is there were several students that didn't take it. For whatever reason, they were unable to find the time to take the midterm. Okay, so with the written exam, you can go into Canvas and you can review the midterm, and I'd recommend that as a study option for the final exam. Just go through there and look at it so you can reference it later for the final exam. The midterm, I want to talk about specifics. So first off, when you submitted the lab midterm, or when you looked at the rubric for it, which you can see in the assignment, there's a rubric for it. There were two things you had to do. And these were really basic things that we've done probably 8 or 9 times already in this semester. And that was to create a new server VM and a new Windows 10 VM. So you had to create it and you had to name it correctly. The first place you had to name it was in ESXi. And you just had to name it WinServer-midterm. And then Windows 10 was Win10-midterm. And then you had to change the computer name. So once you log on to the machine, you go into the system properties and you change the name, just like we've been doing on all of our other machines. And if you did that and you did both of those correctly, you got 10 out of 10 for both of these assessments. So you would have got 10 points for the Server 2019 creation and 10 points for the Windows 10 creation. So right away, you're starting at 20 points. So That was on purpose, kind of some low-hanging fruit, something that should have been easily obtained. This next one, the lab dash LAN, you had to create this in several areas. And again, this was worth 10 points. You had to, in ESXi, you had to create a new internal network called lab-LAN, just like we did with the in week lab 5, where we created the internal network. Same thing here, just create a new lab-LAN, name it that, and then you had to attach those two VMs we created to the lab-LAN, which just means go into the settings and select lab-LAN for the network card. And then you had to create the domain, the midterm.local domain. And then you had to have Active Directory, DNS, and DHCP configured. And you had to, I told you in the specifications, you had to use a 255.255.128 subnet. Okay. So if you did all of that, you would have got 10 out of 10. If you didn't, I left comments in that section when I graded it that kind of said, hey, this is where you lost some points. Okay. And then the next thing that was there is you had to create the users. So, and I asked you to disable the admin account, the administrator account, and then create a new CNET user for admin. And we're going to do this going forward. In our labs, we'll do the same kind of thing as disable the admin account. And that's a security practice because everybody knows what the administrator account name is on every Windows machine. The administrator account name is administrator. So if we can change it to something else, you know, CNET, even admin, sometimes they'll just shorten it to admin, or, you know, they'll use the server technicians user account, or they'll create a separate account just for that, just for security. Because if you don't know what door to knock on, it's kind of hard to pick the lock, right? So we had to do that. And then create the employees OU, and then Steve, Bill, and the owners group need to be inside of the employees OU. All right. And if you did that, that was, I believe, 5 points. And then the DHCP, if you had that set up and it was working on the client, you were supposed to hand out the scope of .150 to .200. Okay. And then you got to create the file share and then map it to the L drive for all the Windows 10 logged on users. So what I did is I logged on to your Windows 10 machine. I logged on as Bill, and then I went into the computer and this PC. And if there was an L drive there and I had read-write permissions, that was good to go. And then I switched user to Steve. If you had the L drive logged and mapped, I would go into the file, try to write, and I should be blocked because Steve's only read. And if you did that, you got permission for the file share and the permissions. All right. So that's the lab part here. Now, the only area that some people got a little confused on. So I'm going to stop this share and share a white screen. So let me share a whiteboard here. So hopefully everybody can see this. Let me just move this around a little bit. So this is kind of from a networking standpoint, but if we have a 255, and it's hard to write with this mouse, 255.128 subnet mask. In slash notation, the number of ones, so how many ones are in 255? Well, that's 8 ones, right? 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. If you sum it up, it's 255. So there's 8 ones here 8 ones here, 8 ones here, and 128 is just 1, 1. So in slash notation, we just add up the number of ones. So 8 plus 8 plus 8 plus 1 is 25. Okay. And if there's 25 ones and we have a total of 32 bits, that means 7 of these bits are for the network. Okay. So these are the network bits are 25. The host bits are 7. So if we have 7 host bits, 2 to the 7th, oh God, that's supposed to be a 2. 2 to the 7th power equals 128, right? And for those of you that have had the networking class or taken it, this probably makes some sense to you. If it didn't, you could have done some quick research and found this. So we know on a typical .0 network, this is /24, and we end up with 24 network bits and 8 hosts, right? Because 24 plus 8 is 32, just like 25 plus 7. So we borrowed one of the host bits to have more networks, less hosts. Okay, that's basically what that is doing there. So if we look at this .128, that means normally in this 2 to the 8th is 255, so or 256. So that means that in this 128, our network that normally would go 0 to 255 has now been cut in half, right? So this first half will go to 127, and the second half will go 128 to 255. So the trick here was with this subnet mask that I gave you for the lab, and then I gave you the range of your DHCP scope, 150 to 200. Well, where will this fit? Is 150 to 200 in 0 to 127? No, it's over here. That number will fit in this side of the network. So what that meant is, now remember this first IP and this last IP, the first IP is the network ID. The last IP is the broadcast ID. So the first usable IP address is .129, and that's what should have been on your server. Okay. Now there were quite a few people that got this perfect. They got everything perfect on this lab. They got 50 out of 50. So, and this was just a little depth that I added in here, just so that you could be able to see what that does to your network. So some of you just left it at .0, and I took off some points for that. Some of you put your server .1, and you couldn't join into the domain, right? Because they're not on the same network. So that's just something I want to show with the subnetting here. All right. Any questions or comments on that? No? All right, no problem. So let me go back to sharing screen 2, and we'll continue with our thing here. All right, so as I mentioned previously, we are now kind of switching gears to Hyper-V. So we're going to take a brief look today, and today Today's lab is also very brief, and we'll walk through today's lab together. I didn't create a video because I want to, make sure everybody's on the right path here. And let's see here. All right. Oh, and just briefly, I want to let you guys know I got an email from a former student last night, and he has a store. It's a business. It's called youbreakifix.com, and they're looking for some technicians. So if you're interested, what he's really looking for is somebody serves customers by diagnosing, troubleshooting, and repairing devices while ensuring customer satisfaction. So he's really big on outstanding customer service. And then you need to be a good problem solver and be organized, strong written and oral communication, work well in the team. And the minimum requirements are just a high school diploma or a GED. He'd prefer that you're A+ or Apple certified, and that you have some experience repairing electronics, smartphones, PC, Macs, and game consoles. So basically his company is, if somebody breaks something, they can take it to him, and you break it, I fix it. So and it's in Chino Hills. And he said he's getting into more and more retail locations. So he's growing and he needs some technicians. So if that's something you're interested in, send me an email and I will forward your contact information to the owner, Mark Brable, and he'll contact you with probably a request for an interview or just to talk to you a little bit. All right. Mount SAC, Ian asked if Mount SAC has Apple certifications. It does not. And unfortunately, to get Apple certified, you have to work for Apple. So you have to have some sort of relationship with the Apple headquarters, either as a salesperson at the Apple store or work at Apple, one of their locations, to do that. So that's one of the certifications that is very, very specific to their business. Okay, so if you're interested, let me know. All right, so let's look at what is Microsoft's virtual technology known as Hyper-V. And Hyper-V was first introduced with the release to manufacturing version of Server 2008. So compared to VMware, which started in the mid 90s, right? 93 is when the first VMware workstation came around. Microsoft came into this very, very late in the game, right? So it's only been around a little over 12, 13 years. But one thing that they have going for them is that Hyper-V is free of cost and is included in every version of Server 2008 and above. So if you have the data center version or the standard version of Windows Server, it includes Hyper-V. So unlike VMware, ESXi, where you have to go purchase it and then add in all the other features that you need, DRS or the failover clustering, the vCenter server, all of the features that we've looked at, that big laundry list of things that you can add into it. With Hyper-V, it's all there. So once you have your server running, all you have to do is go into the roles and features and click on Hyper-V and go from there. Okay, so it's very, very convenient. And this is why in more of the smaller shops where they don't have really big budgets, they're going to use what's free, right? Just like a lot of us, if we're looking for some new technology and there's an option that's free versus an option that's paid for, most of the time we're going to investigate, well, what's the free one do? What's different with the paid? Then we have to weigh, is it worth the increase in cost to get the features that you would pay for? Now, with Hyper-V, it is every bit as capable and every bit as robust as VMware. So one of the other benefits to a Microsoft product is it's part of the Microsoft family, which means once you're semi-familiar with some of the way Microsoft does things, right? The look, the feel, how do I get to this menu? How do I get to this? I mean, you learn those things over the years. Once you're in Hyper-V, that intuition is very, very similar. Whereas with VMware, you know, it looks different, it feels different, the buttons are different, the how do you get to this or that is a little bit different. Now, it's not impossible. We learned how to do that. We got comfortable with it in just, you know, 7 short weeks. But with Hyper-V, you've probably been working with Microsoft for much longer. So there will be a familiarity that's there. Now, prior to Hyper-V, Microsoft had a product called Virtual PC. And Virtual PC was for workstation virtualization. And then in 2005, Microsoft ventured into the server virtualization. So their workstation was Virtual PC. Their server virtualization was Virtual Server. And this was a free download that you could download, and it just created a web page on your server that you would access from any other browser to administrate it. Just very similar to the way ESXi is done. All right. And then in 2008, Microsoft introduced the clustering service. And this high availability feature for virtual machines allowed with what Microsoft calls quick migration. So unlike the failover clustering and the DRS that's in VMware, Microsoft has the similar feature. If you have a Microsoft cluster built, it will automatically migrate your machine from one Hyper-V host to another Hyper-V host that you have designated. All right. Now, with Microsoft clustering services, all VMs are located on a shared cluster storage. So again, that shared storage concept is crucial. It's critical to the functionality of any clustering. You always have to have shared cluster. And if one of the nodes fails, all the VMs running on that node fail over to another node and come back up. Then in 2009, Server 2008 Release 2 was released, and this includes bug fixes for Hyper-V and a new clustered shared volumes. So they improved the clustering. Now, when we work with clusters, it's just another Microsoft wizard, right? If you've ever set up anything in Microsoft, a lot of times when you click Start, it will launch what they call a install wizard or a setup wizard. And with the newer versions of clustering, it is almost drag and drop. So they'll have a picture of your servers that are out there and it'll say, which ones do you want to make the node? You just drag them into the kind of the corral, and now they're part of the node. And obviously you need at least 2 nodes to have a cluster. Early versions of Microsoft server clustering services were notoriously difficult to work with. And one area that they really improved is how straightforward and wizard it is. Next, click, add, boom, done, which is a really good thing now. Now, Hyper-V began gaining favor with IT shops that did not have to install an additional product for virtualization because it's included. So instead of having to determine, do I have another server that I can, kind of use as a training or a lab environment? Do I have a server I can, boot into VMware and designate it just for virtualization? You don't need to do that because if you already have server 2012, 2016, 2019, 2008, or above, it's already has Hyper-V included. So you don't have to go buy anything or configure anything. And then the other main benefit, and Microsoft has done this on purpose, is they have designed their two main server applications. There's their database server, SQL Server, and then their mail server, their Exchange server. They've made those to be optimized to run inside of a virtual environment. So they've kind of made it, hey, if you want to use Exchange or SQL, which are really common enterprise server applications, they've optimized it to work in a virtual environment. So if you have Hyper-V and you want Exchange, boom, it'll pop right in there and work optimally. All right. Now, with the release of Server 2008 R2 Service Pack 1, Microsoft added some more features. So they have dynamic memory and remote FX. Now, dynamic memory uses a concept of you assign memory, but if it needs more, it can grow. If it needs less, it can shrink. So, it's kind of like, have you ever seen some of these prank videos where someone will prank somebody and they'll go into, say, their office or their bedroom, and they'll just blow up hundreds of balloons, right? Now, when they take in 100 balloons or 1,000 balloons, obviously when they're deflated, they don't take up a lot of space. But when you start filling those all up with air, those balloons will take and they'll fill in every nook and cranny of that room's square footage or cubic footage, and we'll use it all up. Well, dynamic memory is kind of that same principle where your memory will balloon up and it will balloon down as needed, but you do have to specify, this is how much RAM I need this machine to use when it starts, and this is the maximum amount of RAM I want it to use, even if it balloons up. So that you still want to set the startup in the maximum size there. Okay, so that's dynamic memory. Now you'll see in today's lab when you install or when you set up your first 3 virtual machines, that it's just a click where you just add in the memory and then go. Okay. Now the startup RAM is dedicated, and just like we talked about in virtualization in general, the memory that you assign you have to have enough on the host machine to support all of your virtual machines. So like if you were able to, now you can't go look at your ESXi server because I reformatted all those yesterday to get them ready for Hyper-V today. But if you would have gone back on there, you would have seen most of you had 9 virtual machines. And if all of those were set to 4 gigs of RAM at startup and you started them all up at the same time, you're going to have a problem because your host machine only had 32 gigs of RAM. So the same concept applies in Hyper-V or any virtual environment. Your VM or guest operating systems cannot exceed the total RAM on the host machine. Okay. Now, the startup RAM is dedicated, while the remaining max threshold limit value will allow the virtual machine to grab more memory from the server's available memory pool on the fly whenever it might be needed. So, it's just like anything. Sometimes, things need more power, need more memory, and other things don't. So if you have 4 virtual machines running on your host, and one of them's kind of not doing a whole lot at that time, it can give some memory to another one. And then when it needs it, it can get it back, or someone else will give it. Okay. So that's what the dynamic memory is. Now, Remote FX was a new feature that introduced a set of end user experiences that are enhancements for the remote desktop protocol that enables a rich desktop environment within your corporate network. Because Microsoft realized people are not going to stand at the console or in the data center at the foot of the server base and enter their commands. They're going to remote into it. So they wanted to increase some of the remote desktop features, which is a good thing for us because that's how we're going to get into our servers. All right. So how do we deploy our Hyper-V? So first off, we're probably going to use Hyper-V to consolidate some of our servers. So some of the box servers, physical machines that we have, maybe 5 or 6 of them, we may be able to say, let's get a beefy server, a good host machine, and then let's create some virtuals and we can repurpose those other machines, those other server, that hardware for something else. We also may want to take some of our physical machines and make them virtuals, or convert some of our virtuals to new virtuals. And one area which is how we use virtualization, is for our research and development. So as a learning environment, this virtualization is great. I mean, there were a handful of students during the lab midterm that disabled the administrator account before they created the CNET admin account. And guess what happened? They got locked out of their machine and they couldn't log in and they couldn't do anything. Well, a couple of you emailed me and I said, probably the best solution is to just punt, right? Just delete everything and start over. Because if you cloned it, it's not going to take but maybe 5 minutes to rebuild that machine and get it to that point. Now, if you're in an actual environment on real hardware, you're probably going to think twice before you just say, well, I'll just reinstall everything, because that could be a lot of work and you could lose some data, you could lose some time and effort for sure. In a virtual environment, it's much, much easier to do that. Okay. The other thing that this deployment scenario will assist with is with business continuity and disaster recovery. And then, of course, all of this is the foundation for cloud computing. So Microsoft's Azure, the foundation of Azure is Hyper-V and virtualization. So it's a really good opportunity for us to put all of these scenarios into play and continue working on our environment that we talked about in week 2. All right. Now, with the increase in multi-core processors, gives you the ability to do more on the same hardware. So single servers with powerful processors can handle a huge amount of workload. So running a single application role may result in severe underutilization. So are we getting the most bang for our buck, right? Are we using all of our resources? Are we getting, some of the accountants will say return on investment? Those kind of things can be greatly improved and maximized with virtualization. So that's what this slide is talking about here. All right. This not only has the benefit of maximizing the cost of the hardware, but it also reduces the cost of the power. And power costs are something that continue to increase, right? the you know, the advent of solar. And one thing I'm really excited about is this hydrogen fuel cell technology, and then the increase in the technology in the batteries, the storage batteries. That's come so far in the last probably 3 or 4 years. But until it's completely optimized and 100% available, power is still something we need to worry about as far as cost overruns. All right, so that we still need to take into consideration how many servers are we running. And I think I mentioned this in week 1 or week 2. On average, a server that's just running, not highly utilized, not barely utilized, just an average server consumes about $15 worth of power every month. So, you know, you start walking around a data center and you have thousands of servers, at $15 a server per month, that's a $15,000 a month electricity bill on average. So, you know, if the company's not making a lot of money, you know, if times get tough, they're going to have to, you know, downsize some areas. And one option would be to downsize the number of servers and go virtual. So, you know, just like everything else in the world, as price goes up, businesses are always looking for ways to either maintain their cost output or decrease it if possible, right? And then another scenario is to go physical to virtual, which there are tools you can download, and you can just point it at a physical machine, and it will like take that machine and suck it into the virtual environment, and now you have a VM of it. So this is a really good way to take a machine that's kind of dedicated for certain purposes. You know, say there's a machine in your finance office that prints out a report, but it's only done once a year, right? Maybe it's part of the annual financial audit where there's some legacy software on there and it has to run this report, but you can't install that software on a new machine because it won't work, because it's not compatible. Well, you could take that machine and let's say it's in your corner of your office or it's in the closet and you have to set it up once a year to run this report, okay? We could pull that into a virtual environment and then get rid of that old machine or save it, you know, for archive purposes, and then just run the virtual once a year, and it doesn't take up any space or power or anything like that. Now, this allows legacy applications to be converted into a virtual machine and run on newer hardware. So that old system, you know, maybe it ran on say a Pentium 3 or a Pentium 4, and it may have been clunky with just say, you know, 2 gigs of RAM. Back then with the 32-bit processor, the max was 4, so 2 was quite a bit. And now you pull it into a virtual that's 64-bit and say, you know, 4 gigs of RAM, it's going to have much better performance, even though it's in a virtual. So you can increase that. All right. Any questions or comments on anything so far? Pause for questions. No? All right. Well, if anything comes to mind, don't hesitate to ask. All right. Now, the other thing is, and this is where we really are going to take advantage of this, is it gives us a lot of flexibility in coming up with ideas, right? So, you know, imagine if you had your own Hyper-V server and you had a bunch of hard drive space and a lot of RAM and enough network bandwidth, and you said, well, you know what, I'm really curious about, you know, fill in the blank. You know, I really like that little 1 week web development thing we did with, using Nginx and IIS, and that sparked a kind of a curiosity in you to, I want to know, I want to design my own internal website and work with all this technology that I keep reading about, or there's this video series on that I like, and I've always wanted to do that, but I didn't have a server or machine I could go buy. Well, if you have Hyper-V, if you have Windows 8 and above, that's enterprise, it includes the client version of Hyper-V, which has an identical interface to the server Hyper-V. Okay, so that will give you the ability to really expand, start testing, start building, start playing around with all these various technologies. If you're really excited about shared storage and storage area networks and network attached storage that we're going to talk about later on, and you're like, I really want to learn how to do that, or if you really like hardening an operating system or looking at the security aspect, doing penetration testing, vulnerability scanning, you could set up some virtual machines, and then another virtual machine could attack them. And you could just kind of coordinate and work with it and see, well, how do I prevent this from happening to my machines? Well, the best way to do that is get in your sandbox and set everything up and see how it goes. Okay. So remember when we talked about the Microsoft Solution Framework and the testing phase? That's where we go out and we, try things out. We see how it works. We make adjustments. Well, a virtual environment is an excellent choice for doing that. So the need to reformat is common, and Hyper-V snapshot ability makes the need to reformat go away, right? We just take a picture of it, snapshot, something goes sideways, we just say, oops, go back to the snapshot, and we're right back where we were. So it gives us a real good, solid, if you were climbing a ladder or scaffolding, and if you knew that if you fell, so let's say every time you climb a ladder, there's a platform that raises about an inch or two just below where your feet are. So if you're up 6 feet, it's up 5 feet, 10 inches. And you go up to 7 feet, it's up, 6 feet, 10 inches. So it's always there. And if you fall, if you fall from 6 feet and the ground is 6 feet down, that's quite a fall. You could probably get pretty hurt. But if you take a snapshot and the fall is only an inch or two, that, you can be a little more courageous in what you're doing. You can be a little more aggressive in how you're going to, well, let's try this. This is kind of a wild idea. Let's see if it works. Oh man, that thing blew up. Well, no problem. We just fell 2 inches. Now we're okay. We can keep going from there, as opposed to falling to the bottom and having to start all over. Okay. So the virtualization gives us that ability. Now, business continuity, remember, this is referring to how a business can survive a catastrophic event or situations. And this allows us to make sure that even if there is a natural or man-made or whatever kind of disaster, we can quickly resume business, right? So the operations will not be affected if the primary facility is unavailable. Now, Hyper-V uses a Microsoft technology known as the Volume Shadow Copy Service, the VSS. And the VSS is the same technology that's on our workstations. If we have Windows 10 and you have a removable hard drive attached to your computer, Windows 10 will automatically sense that and say, do you want to use this for your previous versions or your shadow copies. And if you do, then you know if you go delete a file or rename a file or save a file and you saved the wrong file or you did it in error, you can just right click on it, previous versions, and go back. And depending on how big your storage is, it will have up to 64 copies of it. Okay, so that same technology is used in Hyper-V to help us with this backups. So we're going to talk about backups specifically in another lecture, but the volume shadow copy service is the back end of that. All right, now along the same lines, Hyper-V offers two flavors of migration. There is a quick migration and a live migration. And in a quick migration, a Windows failover cluster is configured with shared storage on which the virtual hard disks are stored. So we're going to work with a different hard disk file name in this half of the class. In VMware, it's a VMDSK file, right? That's the one we had a copy for that. In Hyper-V, it's a VHD or a VHDX, okay? So the virtual hard drive is the name of the file. So those, for any of these migrations to work, they have to be stored on shared storage, okay? So here's two host machines that are clustered, and then the hard drives are shared on a storage area network. So if one fails, it can fail right over. Now, if failure occurs on one of the nodes, the cluster moves the VMs to the other node. In quick migration, while the migration happens, the virtual machine is paused until the migration is completed. So it's just like hitting the pause on, any kind of audio player. It doesn't mean you have to start over, right? It just stops it and you can go pick up right where you left off. With a live migration, provides great flexibility, is typically used during planned migrations, such as when we're doing our patching or updating of the host machine. Now, live migrations are very network intensive, and you should have in your design a dedicated network card and a dedicated network setup for the live migration process. That way it's not competing with your client network for bandwidth, that's pretty scarce already. So you would have a separate, probably a fiber optic network that could handle large transfers in a very fast amount of time. All right. Now, in the cloud services delivery model, the service provider provides computing capabilities, also called a pool of resources such as network service, storage, and applications. And these services are called highly elastic. Now, elasticity is a kind of newer concept. We always have used the term scalability, but normally when you scale up, it's not possible to scale back down, right? Like if you decide, well, I want to do an add-on to my house, I'm going to add an additional room. I'm going to add, 1,000 square feet to my house by extending my house into my backyard. It's going to be 2-story, blah, blah, blah. We can scale that up, but it's not real easy to say, okay, I'm done with that room. Now let's scale it back down. And that's what elasticity is. Now, a really good example of elasticity where it's needed is, imagine during Mount SAC's registration process. During that time, the portal and the student schedule and the class registration process is getting thousands and thousands, tens of thousands of users are attempting to use that portal at the exact same time. So that would be a really good time for it to say, okay, once we're in those registration times, we will have additional servers. We'll scale up. And then when the registration is over or we're in between those times, we will go back down. So instead of just saying, well, we need to buy, 10 more, whatever we have, we need 10 times that much. Well, we don't need that for 90% of the year, right? We only need it for, 10 days in the spring, 10 days in the fall, 10 days in the winter, 10 days in the summer. So a total of 40 days a year, we need a lot, but during the regular time, it's adequate. It's more than adequate with what it is. So with Hyper-V, we can pretty easily do that, right? We can say, okay, let's upgrade, boom, here's 3 more servers in the cluster. When registration's over, let's just power those off. The cluster goes back down to its normal, 7 nodes instead of 10 nodes, or 5 nodes instead of 10 nodes, whatever the scale up is. And, it will handle that pretty seamlessly. Okay. So that's really why we would use Hyper-V. Now, the next part of this is we'll get into some of the specifics of the Hyper-V technology. So I'm going to stop here. We'll take a break. Let's take a relatively short break and come back right at 9 o'clock, and then we'll continue going here. All right. Any questions or comments up to this point? No? All right. Well, I'm going to pause the video and then I'm going to go warm up my coffee. I'll be back at 9 o'clock, so about 4 minutes from now. All right. See you in a little bit. All right. So I'm going to share the PowerPoint again. All right. So the term hypervisor, again, and I know some of this is repetitive because we talked about the very same thing in when we talked about VMware, but it's used to describe the software stack, or sometimes it's known as the operating system feature that allows us to create virtual machines by using the physical server's resources. Now, the first use of the term hypervisor goes all the way back to the IBM mainframe days. And if you think about a mainframe, you had this large centralized computer that had all the resources on it, the hard drive, the memory, the processing, and then you had these what were called terminals that were wired to the mainframe, and the terminals would run programs from the mainframe and then display it on the terminal. And they were normally monochrome, right? Green screen or yellow screen terminals. And all the processing was done in the mainframe. And if you just take that idea and take that mainframe that was in a large room on some university or some company, and if you just put it up in the cloud, and now instead of those terminals connecting to it directly, now all of our devices, whether it's a smartphone or a tablet or a PC or a laptop, whatever it is, we connect to the cloud. It's the same concept of the terminal. And the back end of cloud computing we know is virtualization. And so it really fits this idea of the hypervisor, which was used in the mainframe technology. Now, the virtual stack looks similar to this, where we have the hardware and then the ring 1, and then the ring 0, remember, gets moved up. So even though this is showing it in the layer that it actually occurs, logically, ring 0 runs before ring 1, right? Because in our stacked in architecture, that's the way it's designed to do it. Okay, and the different systems here, and notice this shows kernel mode and then user mode. And kernel mode is with our operating systems, right? If you've taken CNET58, you've heard these terms before. Kernel mode is closest to the hardware. User mode is closer to the end user or the application. So the kernel mode is very specific to the hardware, and then the user mode is used for the user. Now, the diagram shows that Hyper-V behaves as a type 1 hypervisor, which means there's nothing between it and the hardware. So running on top of the hypervisor are the parent partitions and then one or more child partition. And a partition is simply a unit of isolation within the hypervisor that allocates resources. So either the memory resources or the processor resources. All right. Now, the parent partition is the partition that has access to the hardware devices, and it has control over the rest of the stack. So the parent partition has the right to create child partitions and then manage the components related to the children that the parent created. Now, the child partition gets created by the parent, and all the guest virtual machine components run under the child partition. All right. Now, when we install the Hyper-V role, right after we start the server to complete the installation. Now, unfortunately, or depending on your vantage point, maybe fortunately, but unfortunately, you are not, because we're remote, we're not able to do this part of the process. Normally, this week 9, the first lab on Hyper-V is where we take the servers out of the rack, we reformat everything and install server 2019. And then once that's done, we install the Hyper-V role. And it's during this install, it looks like we already have an operating system, right? Server 2019 is the operating system. Then we install Hyper-V. It would be easy to say that is a type 2 hypervisor because it's running on top of the operating system, right? Which is the definition of type 2. But what happens is once it restarts, this whole picture changes back to where now, even though this is shown above ring 1, ring 0, this actually gets moved logically right on top of the hardware. So once we restart the server, and that restart can take, 5 minutes because it's reorganizing all of the things and saying, okay, now Hyper-V is on the hardware. And a really good way to tell that it's a type 1 hypervisor is on your machine. So if you have Windows 10 at home and you install Hyper-V, and then you say, well, I'm going to try VirtualBox, and you run VirtualBox at the same time as Hyper-V is already installed, VirtualBox will tell you cannot run because your hardware doesn't support it. And the reason it gives you that error is because Hyper-V has taken over all that hardware. It's become that hardware, right, as a type 1 hypervisor. So it's easy to see that. Okay, so now server operating system runs on top of the hypervisor's parent partition layer once the reboot occurs. Now, I've already done this for you, right? I spent, probably 6 hours yesterday on campus where I worked on all the servers and reconfigured them and installed Hyper-V. And the reason we can't do that remote is because there are certain things that you have to do physically on the machine to get this working, or to make sure it's available. There's a lot of things that can go sideways, so I didn't want to do that virtually. All right, so let's look at some of the general features of Hyper-V. First of all, it's a 64-bit native hypervisor that's used for virtualization. You can run both 32-bit and 64-bit virtual machines. So if we have a 32-bit OS like we do with the Windows 10 eval, or a 64-bit OS like CentOS 8 and Server 2019 or 64-bit, they'll run just fine inside of it. Now the server must be 64-bit because Windows Server only runs on 64-bit processors. You can have a single processor, a uniprocessor, and or multi-processor virtual machines. You can create virtual machine snapshots, which capture the state of the running virtual machine. And the snapshots record the system state so that you can revert the virtual machine to a previous state. So a snapshot not only captures the data that is changed in the VM. So like say we had a website and we modified a bunch of code, and then before we did that, we took a snapshot, modify the code, and run it, and it has a failure. Not only will it revert the software, but if we change the amount of memory from the snapshot to the new version, it will also revert back to the older memory settings. So it's not just the data that gets snapped, it's everything, okay? The features include virtual LAN support, so we can create our own virtual networking. It has the features of it conforms to the Microsoft Management Console, which is the MMC management tool. So you can import certain Hyper-V functions into a regular management console. It has the documented Windows management instrumentation, which allows it to work with scripting and other management software that's WMI compliant. It is capable and integrates with Microsoft's clustering services, which allows us to have quick migration and the live migration. And it is compatible with the volume shadow copy service, which allows us to use our backup agents and some of our other backup technologies within the Hyper-V environment. And it also has the fixed, which is a pass-through disk support. And we're going to talk about hard disks in Hyper-V in another couple of weeks, and we'll come back to this fixed disk support. This is actually the fixed disk is the fastest hard drive we can add into our virtual environment, but it is probably the most limited as well. And we'll describe and define those limitations in a future lecture. All right. Now, the clustered shared volumes was introduced as a special type of storage for clustered virtual machine instances with the support for live migration. So in addition to Quick, you have the live, which was added to the inventory of Hyper-V. So even though I mentioned that Hyper-V has not been around nearly as long as VMware's product line, Microsoft has made a very significant investment into the feature set of Hyper-V. So, one thing you have to give Microsoft credit for is they are always striving to be the biggest and the best in the industry. Now, I don't know that they have the horsepower, either from a technology standpoint or from a historical standpoint, to actually surpass VMware. But they were saying the same thing about Microsoft's cloud services, that they would never get close to Amazon, and they have really closed the gap in cloud computing with Amazon. So never say never with Microsoft. All right. Now, the dynamic virtual machine storage improvements for virtual machine storage include support for hot plug-in and hot removal of the storage on a SCSI controller of the virtual machine. So by supporting the addition of or removal of virtual hard disk and physical disk while a VM is running, it's possible to quickly reconfigure the machine to meet these requirements without downtime. Now, remember in our server, the server plus class, and specifically, we talk about downtime is not usually measured in minutes, it's measured in dollars, right? So when a large corporation is down for a short amount of time, it can add up to a lot of lost revenue. So they want to, Hyper-V's capable of supporting hot swappability. All right. The enhanced processor support for up to 64 physical cores. So this increased support has made it possible to run even the more demanding workloads on a single host. This also provides support for second level address translation, or SLAT, and CPU core parking. And the core parking allows Windows and Hyper-V to consolidate processing onto the fewest possible number of processor cores, and then suspend the inactive cores, which will decrease the amount of power that the processor needs. And we know if we decrease the power, we decrease the heat, we decrease the cooling, we decrease the cost, right? So they're looking at all that to really take advantage of that, to manage it all. All right, now, one of the major enhancements to Hyper-V on Server 2012 is an increased ability to perform automation tasks using PowerShell. And we're going to have a lecture and a lab in a couple, probably 3 weeks from now, where we'll use PowerShell. Now, we've seen PowerShell, right? A lot of the Windows server management stuff we showed on the slides had reference to PowerShell. But PowerShell, imagine the shell in Linux, right? The bash shell, and the command prompt in Windows. If you smash those together and then sprinkled it with, whatever would give it the most power, say a radioactive spider for Spider-Man strength. If we mashed all that together, that would be PowerShell. And PowerShell really is, for lack of a better word, powerful. And every version of server and every version of Hyper-V includes more and more features that can be done via PowerShell specifically for Hyper-V. So in 2012, they included 164 built-in PowerShell commandlets for us to work with and customize their Hyper-V environment. So when we do our lab on PowerShell, which again is coming up in a couple of weeks, you'll be able to see where you can literally turn on all your VMs from one command. So instead of clicking on them, start, power on, connect, all that, you can just run, boom, 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 enter, and it'll run through and turn them all on for you. And you can do that remotely as well. So with PowerShell, and remember the benefit of a command line interface is the ability to run scripts. So, if we're managing one Hyper-V server, that's our host machine, it's probably not that big of a deal to log into it, remote into it, and do the task by point and click with the GUI. But if we had to manage 1,000 host machines that have thousands of virtual machines, logging in and clicking on 1,000 different remote connections would be kind of a drag, right? That would be kind of a bummer. So PowerShell gives us the ability, and the command line in general gives us the ability to run scripts to take advantage of that. All right. Now, Hyper-V also has improved dynamic memory. And with these improvements, Hyper-V 3 can now attain a higher level of consolidation with improved reliability and the improved reliability for virtual machine restart operations. So there's two areas that dynamic memory has been improved upon. The first one is the availability where you can set the minimum. So prior to 3, only the startup memory and maximum memory could be are available. This required more memory to be allocated because we know when you power on something, it normally requires more resources. Then once it's on, it kind of settles down a little bit. So the minimum memory in version 3 allows us to have it kind of scale back to the minimum amount. Then the second improvement happened around the dynamic memory concept in the second level paging, which is a cure for problems such as memory shortage. Right? Now, second level paging provides an alternative for the memory on a disk, which can be used in case there is no available memory. So this is similar to our virtual memory, right? With our pagefile.sys in Windows 10. It can do the same thing with virtual machine memory using the hard disk. Now we know that the best performance of virtual memory is solid state. So the same thing would be true here. So it gives us a virtual machine that's configured and required startup amount of RAM. All right. Any questions on any of the features? No? All right, good. And again, you have access to these slides, so you can always go back and read them and digest them at later consumption. All right. Now, what are the hardware requirements? Now, this is where the evolution of Hyper-V is very evident. So the difference between the early virtualization products and the Hyper-V is mainly in the processor requirements. Where early products could run on any processor, Hyper-V requires a 64-bit processor. So you have to have a 64-bit. So if you have an older machine that's a 32-bit processor, say it's a Pentium 2, Pentium 3, earlier Pentium 4s, they are not 64-bit, they're all 32-bit. And you're not going to be able to use that hardware for Hyper-V. Now, the processor also must have the hardware-assisted virtualization. So it has to have the capability that we talked about in week 2 with the HAV. So the processors that support hardware-assisted virtualization provide an additional privilege mode above ring 0, which is referred to as ring 1, in which the hypervisor can operate, essentially leaving ring 0 available for the guest operating systems to run. Now in Intel, that's called virtual technology or VT, and then AMD uses the term AMD-V. Okay, so it has to have that. So even if you have an older 64-bit processor or a power conscious 64-bit, you know, a Celeron or whatever the AMD is, the Phantom or whatever it is, it has to support hardware assisted virtualization, which some of the low end processors don't. That's where they save some money. Okay. It also must have the hardware-based data execution prevention, which is the DEP. And this allows the process to mark the memory as non-executable. So even though the memory may not be utilized, it needs to be reserved for the virtual processes. Now, in Intel, that's referred to as execution denied or prevention, XD. And then in AMD, it's called NX for not executable. Okay. Now, if your processor has virtual technology, the hardware assisted virtualization enabled, it will automatically have this. They go together. So if you go into your BIOS or UEFI of, say, your home machine, and you look under, sometimes it's under the security tab, go into the advanced and then security, you may see where these features are in the BIOS or the UEFI where you can configure them. Now, most motherboards, by default, these are turned off. So if you have a brand new build or a new system, now server motherboards, they'll be turned on because they know servers are probably going to use for virtualization, but gaming machines or desktop machines, it's probably turned off. So if you go to install Hyper-V, it may give you an error, say can't do it, your processor is not supported. It's probably just, it's not enabled in BIOS. It probably supports it, it's just not on. Okay. Some of the other processor requirements, if it's an Intel, it has to have be 64-bit, support for the execution disable bit, and then have the Intel VT, AMD, same thing with the AMD-V. All right. Now, other storage requirements that we need to be concerned about is the hard drive capacity. Now, one major difference between Hyper-V and VMware's ESXi is that Hyper-V can and does run on the same volume that our virtual machines are stored on. So unlike ESXi, where we had our install was on a thumb drive of ESXi, the hypervisor ran from the thumb drive, and then our storage was a hard drive that was in the server. And we had to create a data store, right? And then go to the data store to install everything. With Hyper-V, it's all on the same hard drive. So now our servers, they just have a single C drive. That is the 1.82 terabyte drive that's in the servers. That's where everything will be stored, okay? Now, in reality, if we were to do this, you know, by the book, best practices, we would install a secondary, smaller, probably solid state drive, and that's what we would run Hyper-V on, and then we'd use the internal drive for our storage. And depending on what our VMs are doing, we may move those to better storage or faster storage. Now, there's going to be multiple concurrent sessions on the storage. So disk storage with fewer disk spindles will provide poor input output. So in our systems, again, I said this is not best practices. This is practical. I mean, this is how we are going to do it just because we're testing. We're going to use the same disk drive for our virtual machines as we use for our hypervisor, which can cause poor performance. Now, we won't notice that because we're, you know, running these VMs for a couple hours once a week. I mean, they're not doing a lot. Okay, now it's always recommended to use storage with more spindles for Hyper-V, which provides better input output, which provides better performance. Now, for sound storage planning of the hypervisor and virtual machines, there are a few elements we should be aware of. One, the type of storage, right? Is it solid state? Is it SATA? Is it serial attached SATA? What's the speed of the disk in RPMs? What's the latency speed, and so forth. And then, of course, the size of the storage. So for the VM, normally the first thing you worry about is the size. And generally speaking, you should have an idea of how much storage that particular VM is going to need and do that up front. You can increase the size of the virtual disk later, but it can cause problems. So generally speaking, if you know, say it's a web server and you're like, this website is not going to get over, say, 100 gigabytes, allocate 100 gigs of disk space and when you create the VM. That way you're all set. Now, many virtual environments have more than enough processing in memory, but the storage may be a problem, right? If we take our servers, 32 gigs of RAM, the Xeon processor that's in there, the E6 processor is very powerful. We're probably not going to run out of horsepower, but we may run out of only having less than 2 terabytes of hard drive space. Because if we get some bigger file shares, say we have a file share server, I mean, a minimum we want to create those file shares would be 500 gigs or half a terabyte. So you do a couple of those and you're out of space in a matter of, 2 VMs take up all your hard drive space. So the storage is something we want to consider, the size. The use of SATA is probably the first option because that's normally what's in there and it's very inexpensive and it has decent read-write speed. Now, serial attached SCSI is faster, but they're going to require specialized disks, right? 10K to 15K RPM, and the controller card has to support serial attached SCSI. All right. And then fiber channel have similar performance to serial attached SCSI, but it has a different interface with the fiber connectivity. And then that's our disk. Now, when it comes to memory, it's always recommended to plan not only for current needs, but future needs. That's a challenging sentence because a lot of times we're not exactly sure what will this VM need 6 months from now. I mean, today it may only need 2 gigs of RAM, but a year from now, it may need, 16 gigs of RAM. And knowing that, we have to manage all this somehow. Okay. Unfortunately, or fortunately, a lot of these VMs are you set them up, you turn them on, and you literally forget about them, right? It's like, where is that machine? Oh, that's been running in a virtual for the last, 18 months and never had a problem. So out of sight, out of mind. And sometimes that will also lead to out of sight, out of mind, out of thought. And, that machine may be underperforming due to lack of memory, and you may have to come back in and adjust that. So Ian just asked a question in the chat. Could you do RAID off of multiple USB solid state drives? You can, but you're going to be limited by the USB interface. That will be the bottleneck. So you never get the advantage of actual solid state performance from either SATA or from the PCI Express bus. because USB is significantly slower in the throughput and the bandwidth compared to PCI Express, especially. But you could, I mean, it's possible. All right, we also, just like we think about memory, we should think and consider the network requirements. You know, a lot of times when we set up the networking, it's just a challenge, probably is the right word, challenging to get the networking to work, let alone to get it optimal, right? So phase one is, can we turn it on? Does it do what it's supposed to do? Phase two is it optimized for everything we need? So, you know, that we also need to consider the networking. And that can be a hard after the fact add-on. Now, in the virtual environment, it's not too bad, but in the physical areas, you know, if you say, well, I need a separate fiber optic connection between my virtual machines and the storage for the backups, it's going to be challenging. I mean, if you were on Mount Sax campus and you said, well, I'm just going to pull another cable between here and there, and then you open up those concrete walls, it's going to be a lot of work to get that cable in there. I mean, unless they, you know, left a conduit and a pull string for you, which probably isn't there. You know, that's a big project to pull that, do that kind of cabling. So networking can be a problem. Okay. Now, some of the other options with our networking is, are we going to cluster? Are we going to have a private network for clustering? Are we going to have a migration network? Are we going to have a Hyper-V replica traffic network, which means that's where we're going to do some of our backup work on? Are we going to have a management network? And a management network is a network that only is accessible by our IT staff. So people, your server admins, your server managers, your server technicians, on their desks, they should have access to normally it'd be a virtual LAN that they can access, but everybody else can't see that. Because we would never want to have on the same network a user, if they got the username and password and they remote into our server using remote desktop, that would be a bad deal, right? We just want to prevent that. So the management network is referring to where we isolate it for only our managers. So only our server admins and our network technicians and, you know, system admins, they're the ones that should be able to access these things, but not everybody else. Okay, and then for using iSCSI storage area network, we would have that shared network for our SAN connectivity. Okay, now the versions that are available. Now, Microsoft got away from the term enterprise after Server 2008, and they just basically said, we don't need 3 different versions. Let's just do 2. A standard, which is the same hardware is supported on standard and data center, but data center supports more licensing. So it can go much larger. Okay. So 2012 and beyond is all standard and data center are the 2 versions. Now, for our Hyper-V host machine, you need a minimum of 2 gigabytes of memory. And the maximum for Server 2008 is 1 terabyte. And for Server 2012, 2016, and 2019, it will go up to 4 terabytes max. Now, I have never seen a hard drive or a motherboard that supports more than a terabyte of RAM. So these maxes are almost unimaginable right now, but they can go up to it. Okay, for the guest machine, so that's the host machine, that's our server. The virtual machine inside of it the minimum memory depends on the operating system. So there are some versions of Linux that will happily run on 512 megs of RAM. So half a gig of RAM, it'll fire up and run without any issues. For Server 2008, the maximum amount of memory you can give to each virtual machine is 64 gigs. And then for Server 2012, the maximum memory that you can give per VM is 1 terabyte. Okay, so again, those are kind of theoretical values, not actual. I mean, they're not available as of today, but who knows? A year from now, 2 years from now, they may be common. All right. Now, installing Hyper-V requires that you have a minimum of 10 gigabytes of disk space on the server. If you're going to store the virtuals on the server, you need more than 10 gigabytes to store the virtuals as well, right? So again, the hard disk needs of the virtual need to be considered in this process as well. All right. Now, the host machine hard drive must have adequate available space for the virtual memory paging file to operate properly. Now, remember in like CNET50 and CNET52 and 54, we talk about Microsoft always recommends 30% of disk space should be available. And it says that's where Microsoft will use that for your virtual memory of your hard drive. It will use that space. When you burn a CD, it needs space. When you install an application, it needs temporary space, right? All that area. So if you are doing Hyper-V and you want it to perform optimally, it's going to need that virtual memory or the page file.sys. Now, normally you want a 1-to-1 ratio of RAM to page file. So if you have 32 gigs of RAM, you should have at a minimum of 32 gigs of hard drive space, right? So that way they can operate there. Now, Microsoft has done an excellent job over the years of managing the paging file. It does it automatically. And normally as a technician, we leave it. We can manually change it if we wanted to, but there really is no good reason to change it, right? Leave it, let Microsoft, let Windows handle that for you, whether it's server or workstation. All right. Now the guest VMs also need to have adequate paging file considerations. So even though they're a virtual, the OS is going to operate as it normally would. So if you have a really tiny hard drive in your virtual machine, it's going to affect the performance of the rest of the machine. So you want to make sure that you take that into consideration as well. All right. So what operating systems are supported by Hyper-V? And by support, I mean, if you have a support agreement with Microsoft and you call them up, they will be able to offer technical support for it in a Hyper-V environment. This is where Microsoft, whereas VMware supported just about everything, Microsoft narrows it down a little bit. So they're going to obviously be very supportive of all of the Microsoft products. So you can see they go all the way back to Server 2003. And they're somewhat supportive of Linux, with really only 3 of the operating systems that they support: CentOS, Red Hat Enterprise Linux, and SUSE Linux Enterprise. So if you're using Ubuntu or any other version of Linux other than CentOS, Red Hat, or SUSE, and you call them up for support, they'll say, we're sorry, that product's not supported. That does not mean you cannot create a virtual machine of Ubuntu in Hyper-V. You certainly can. It's just not officially supported. All right. So this is one of those areas where if you're going to have your website on Ubuntu and you need support, that may influence you to use VMware versus Hyper-V. Okay, so all this kind of comes into play into our selection. All right, and of course it supports the Windows desktop operating systems as well as their server. All right, now there's two versions of Server 2019, Standard and Data Center. Standard only gives the user or the license holder one free license for a virtual machine. So if you have Windows Server Standard, you can run that same version, that same license with the same code or product key in one virtual machine. If you have Data Center, you can have unlimited virtuals of Data Center. Okay. Now in this class, we're using the trial version, right? The 180-day evaluation. So we don't run into the licensing problem. But if you're in a business environment, you may want to consider what are we going to do with this? Now, if you have Standard and you want more than one virtual of Standard, you just have to buy additional licenses. So you can use the same install media and then just put a different product code on, and it will work fine. All right. So that kind of gets us an introduction into Hyper-V. So we looked at in this first half of the lecture, first part, the history and the background. We talked about some of the deployment scenarios. We investigated the architecture, and then we looked at some of the features and then the hardware requirements. Okay, so any questions on basically if someone were to say, what is Hyper-V? At this point, you should be able to say and answer it from these kind of bullet points. All right. Any comments or concerns at this point? Okay, Robert says he's all good. So if you're all good, I'm all good. So I'm gonna stop this share. Let's take same with you, Luis. Thank you. So I'm gonna pause the recording. All right. Well, welcome back from the break. Let's finish up today's lecture, which with a look at the install and configure Windows Server. All right. So hopefully you can see those screens as well. And when we install Hyper-V, first we have to install Server 2019. So what I did yesterday is I just created some boot media and booted each server, took out the ESXi thumb drive, put in the boot media, and then installed Windows Server on each of your machines. Okay. So the objectives are here. And again, some of the terms, the VM refers to the virtual environment that emulates a physical computer's hardware and BIOS. The guest operating system is the operating system installed. And remember, the OS does not have to be changed, right? There's no modification to that. So the machine or the operating system we use in a virtual is identical to the one we would use on regular hardware. The host computer is the machine or computer that the VMs run within. And then the software of the virtualization is how it is all of it managed, created, and installed. So that's the hypervisor there. All right. Now the hypervisor creates and monitors the virtual hardware. There's two types, type 1, type 2. The virtual disks consist of files on the host computer that represent a virtual machine's hard disk. And it's files, plural, because sometimes we're going to have different connections based on the parent disk, then we may have child disks that are created from it. So it's going to be a little bit different than the way we handle things in VMware, in that we actually use Hyper-V to create a new differencing disk based on the parent disk. Now we're going to get in all that next week. This week we're just creating the parents. So we'll go through that process. Okay, and then we can have virtual networks, and we can have checkpoints, which are used for our snapshots. All right, so here's a typical configuration here where we have the hardware layer, the type 1 hypervisor, and then the parent partition where it's the Hyper-V management console, which is built into the operating system. In this case, it's Server 2012. It could be our environment, which would be Server 2019. And then within our space, we can create child partitions with applications and guest operating systems within it, right? So this may be our CentOS machine. This could be our Windows 10 machine. Okay, so that's just a good diagram of that. All right, now installing Hyper-V, we need at least a 1.4 gigahertz or faster 64-bit CPU. It has to support the, if it's Intel, the XP, execution prevention. Must have enough free disk space to hold the operating system you're going to install, and then enough RAM to equal the minimum amount required for each of the servers plus the VMs. So in our case, we're going to keep our VMs no more than 4 gigabytes per virtual machine, right? Now, Server 2019 with Hyper-V includes licenses for virtual instances. If it's standard, there's one license. If it's data center, it's unlimited based on your resources, all right? So we're using the data center trial. So we have unlimited licenses of Server 2019 inside of it. All right, so in Hyper-V Manager, all tasks related to creating and managing virtual machines are listed in the action panes. So it's going to, and I'll show you this in just a second, but Hyper-V looks and feels a little bit different than VMware. Now in the VMs, they actually consist of files with, again, the two main files being the configuration file and then the disk, hard disk file. In addition, you might have other files that, such as the differencing or checkpoint files or a save state file. Now, the process for creating a VM is you start the new virtual machine wizard, create the new VM, give it a name, choose a location for the VM. And for all of ours, we're going to use the default location, which is the public location for all users. So if you go into the C users, all users, or public, that's the location. And if you just click next, that's the right spot. We can use Gen 1 or Generation 1 or Generation 2. For our machines, because they're going to be fairly standard sized, not a lot of memory, not a lot of hard drive, we'll stick with Generation 1, okay, which is the default. So if you get to that screen and you're not sure, just click next because the Gen 1 will be there. We'll assign the amount of memory, and that'll be in the instructions. We'll configure the networking, and then we'll create a virtual hard disk, and then we'll do the install. So a running VM does not require using Hyper-V Manager. So you can have it running and close Hyper-V and it still be running in the background. You do need Hyper-V Manager to change its, configure and change its properties or to access it locally. which is how we're going to do it. So we're going to use our Hyper-V manager quite a bit. And you can connect to a VM a lot of different ways, just like Microsoft, right? Like if I said open task manager, some of you would do control delete task manager, some of you control escape, some of you would do start task man, and you know, there's a million ways to get there. Same thing here. To connect, right click the VM and click connect, double click the VM, select the VM and double click its screenshot, select the VM and click connect in the action menu. Okay. The virtual machine connection console has the following toolbar icons. The control delete sends that keystroke to the VM. So that's how we're going to send control delete, is on the taskbar. There'll be a little, or the toolbar, there'll be a little 3 little dots, you know, that looks like a key plus a key plus a key. That's the control delete key. Starts the VM, turns off the VM. Shut down. Now turn off is like pulling the power plug. So just power completely turns it off. That's not the preferred way of shutting down a VM. The best way is use the shutdown, which will send the command to the OS to trigger the shutdown within the VM. So save saves the state, pause pauses, reset resets it to a state, last known save state, and then the checkpoint creates a checkpoint. All right. Now, you also can do a revert or a session mode. That's there. We are not going to, in this class, we're not going to use session, revert, checkpoint, reset, pause, or save. We'll use the control delete key and then the start and the shutdown. Okay. Now, some tasks you can perform with other menus. There's a file menu that accesses the VM settings and allows you to exit the VM. The media lets you specify the ISO options for the virtual CDs. Clipboard copies a screenshot of the VM to the clipboard. View will toggle the display of the toolbar. VMs can be created by using other methods other than the new virtual machine wizard. You can do an import, you can do a copy, or you can do a convert. Okay, so those are all tools within the Hyper-V manager. Now, if we're going to export VMs, which we're not going to do that in this class, but you can use Hyper-V to export and your VM and then import it into another host machine later on. This is a form of a backup. You can even export a running VM. Okay, so if the VM's running, you can still export it and it will work fine. After it's exported, it can be moved. The VHD file or the folder that it's in can be copied to any other location and then copied into a new location, or use the import and then point it at that location and it will pull it in to your new machine. All right. Now, starting with 2012 R2, you can import a VM that hasn't been exported. So if you can see the hard drive and the location of the machine and copy it, say, to a USB drive, and then connect that USB drive to your new server, you can do an import even though it's never been exported. Okay, when you do this type of import, you can register the virtual machine in place, restore the virtual machine, or copy the virtual machine. So again, we're not going to do any importing and exporting in this class. Okay, we can also just copy the hard disk. So to do that, you just find the VHD or VHDX file, copy it, create a new virtual machine, and then use an existing hard disk and select the hard drive that you just copied. And that would be similar to if I took my home computer, took out my hard drive, went over to, Louis' house, put my hard drive in his computer and turned it on. That would still be my computer now. not his, right? It would be my hard drive on his machine. The same concept with copying the virtual disk. All right. We can also do a conversion from a physical machine to a virtual machine. There is no built-in tool by default. However, if we use the Microsoft System Center Virtual Machine Manager, which we'll take a look at that later on, we can use that to do a physical to virtual. There's also a free utility Microsoft created called Disk2VHD that you can download, and you can point it to the machine you want to virtualize, and it will take that machine and create a virtual hard disk of it, and then you can import that in. All right. Now we can use PowerShell to do all of this. We'll come back to all this PowerShell in another lecture, but it's easy to create a new VM, configure it, and then start it up and do the install all within PowerShell. Generation 1 and 2. Now we're going to only use generation 2. Generation 1, sorry. We're going to stick with Gen 1, but Gen 2 have enhanced capabilities. They, instead of the BIOS startup, they use the UEFI, and they have better device support. It supports network boot with IP version 6, and it supports the VHDX hard drive, which is larger. And then it has the GPT boot versus the MBR boot. Now, they also allows you to do the live disk expansion, reduce attached surface, and it supports the secure boot that is built into the newer Windows operating system. You can convert a Gen 1 to Gen 2, but you can't use a Generation 2 VM on a Hyper-V server before 2012 R2. So if you have a legacy network system where you may have some older server 2012 Hyper-V machines and some server 2008 machines, you don't want to convert them to Gen 2 because they won't work in between those. So Generation 2 VMs only support Windows 8 or Windows Server 2012 and newer. So again, if you have older VMs, they have to be Gen 1. So for this class, make everything a Gen 1. All right. We can create virtual networks in Hyper-V, and the virtual networks are connected to a virtual network through the virtual switch manager or in PowerShell. Now, each virtual switch is a separate virtual network. So if we create a new switch, it's like taking a physical switch and sticking it on our shelf. That is a separate network. So keep that in mind. Now there's 3 types: an external, an internal, and a private. An external switch must be 1-to-1 ratio with an external or a actual network connection on the server. Okay. Now on our machines, we only have one Ethernet connection that's on, that's actually connected. All the other ones are, they'll show up, but they're not connected to anything. Okay. So the one, and when you install Hyper-V, it creates its first external switch. So in our instance, that's our only external switch. All of the other switches that we're going to create will be internal. And the difference between an internal and a private is on an internal switch, the host machine can see the virtual machines that are connected to the same switch. A private switch, only the virtual machines can communicate. Okay. Now to create, delete, modify virtual switches, you use the virtual switch manager, which is in the action pane, or you use PowerShell. So an external switch binds a virtual switch to a physical network adapter. Only one network external switch can be created per physical network adapter. You can use an external virtual switch when external computers must have access to the VM. or when the VM must have access to external. So if we have an external switch, it's like plugging it into the same network that our host machine is on, all right? Having more than one physical network card is recommended, especially if you plan on using multiple external switches. Now you can dedicate one of the networks to NICs to host communication, and the other NIC can be bound to external virtual switches. When it's designated using the external virtual switch, Windows binds the Hyper-V extensible virtual switch protocols to the physical NIC and unbinds all the other protocols. So if you look at the network properties of that switch, you'll see that it gets modified by Hyper-V, which is fine. I mean, we're not going to really get into that. Just know that that has already happened for our machine. So here's a picture of the physical network connected to a physical network card connected to the virtual external virtual switch, and then our VMs. So in this case, VM1 and VM2 would be on the exact same network as the host machine. So in our environment, that means that by default, we know our operating systems use DHCP, so they would get an IP address from our 10.29.72 network. So that's the way that would work, okay? An internal switch, again, only allows the VMs connected to that internal switch along with the host machine. Now, because it tries to use DHCP, but there is no DHCP to answer, it will get the automatic private IP address, the 169.254.something.something address, okay? So if you do an internal, we have to build a DHCP server, which we will definitely do. All right, so here's an internal switch. Now, a private switch, only the VMs are connected to it. So if we look here, now our VMs are completely isolated from the host. So if we need these VMs, now obviously in this scenario, only the VMs can communicate. They have no access to the outside. So the only way we could configure these VMs is with the Hyper-V manager, because we couldn't remote into them because they have no outside access. All right. And any questions on the external, the internal, or the private switch? Again, we're going to use the external switch to get things going, and then we're going to use internal switches to isolate everything. All right. Now, communication, if we need communication in between our networks, we need a router, right? A definition of a router is it's a device that interconnects two or more networks. So you can do that either by creating an external and a private virtual switch, then configuring one VM with two NICs, which would then be the router, or we can create an internal virtual switch and enable routing on the host machine so that it routes between the internal and the physical switches. Okay, so in this case, again, to get these networks together, if these are internal, they must use a router. All right. We can use virtual LAN and virtual LAN IDs. By default, we'll just leave these settings unchanged, and they'll work just fine. But we can do VLANs and VLAN IDs within Hyper-V. Just like we could also do that in ESXi as well. Okay, some advanced configuration. We can go in and configure the MAC address on our virtual machines, right? We can change it if we need to. There's some advanced features on the network adapter, and we can enable single root input-output virtualization. For some of the performance, we can increase that if we need to. All right, with the MAC address, the Hyper-V will assign a MAC address to every network adapter. Hyper-V, the pool contains 256 addresses, but you can make it more if you wanted to. Basically, it's saying on your host machine, you're not going to have more than 256 unique network cards in there, in your virtual environment as well. To expand the pool, you change the second to the last byte, and then that will increase it. And remember, on our MAC addresses, the first half are of the first three bytes are the OUI, the organizational unique identifier. The last 3 bytes or last 24 bits are for unique address. All right. So here's where you can go in and modify the range here. So this basically says it starts 00155D, and this is the OUI for Hyper-V, and then it goes 010200, 0102FF. So that will go these 16 bits, because each one of these hex characters represents 4 bits. So this is 8 bits of data, and 2 to the 8th is 256. So you could change this to 03, and then you'd have an additional 256 there. All right. Now, you can also do some advanced configuration on the features of the network. You can enable the MAC address, enable MAC address spoofing. So if you want your virtual machine to have the same MAC address as another machine, like maybe for switch security, you could do that. You can enable DHCP guard, router guard, protect the network, and you can also mirror ports. So it's similar to some of the functions of a managed network switch, a layer 2 device. You can do the same things in your virtual switches. All right, here's some other additional information with the single root. And this allows a virtual adapter to bypass the virtual switch software and communicate directly with the physical hardware. That has to be supported by the network card, the PCI Express network card that's installed. So you may have to update the drivers or have the right drivers. That's why, have you ever purchased a network card and it may say this is designed for a server? That means it's probably going to have some of these features, whereas a typical one might not. All right. We can do teaming on our network cards, which just basically says, I'm going to take the bandwidth on this card and add them together. So now I have this much bandwidth. So instead of, this pipe, now I have pipe twice as big. Now in virtual machines, you can use the same procedure as on physical computers, and teaming can be configured only on VMs that are connected to external virtual switches. If they're internal, it's all done in software. If it's external, it relies on the actual physical network card. If network NIC teaming is configured on the Hyper-V host server, configuring it on the VMs is not necessary, right? So if you do it on the host, the VMs will get that additional bandwidth automatically. All right. Synthetic versus legacy network adapters. The only place we will run into this is if we want to use the PXE boot, which means we want to boot from the network. In this class, because we're virtual, we're not going to boot from an external Windows deployment server. We're going to build our own Windows deployment and have it internal, which will work just fine internally. However, if we wanted to connect to the Windows deployment server that I've configured on our network on campus, we would have to use a synthetic network adapter, because the default one don't work. They don't have PXE boot options. Okay, so just consider that if you're building a VM and you need to install an OS from a Windows deployment server or some other deployment system, you want to use a synthetic adapter versus the legacy, or you want to use the legacy, not the synthetic. Okay, fiber channel can be configured as well. I'm gonna go through some of this fairly quickly. So here's the settings. So this looks a little bit different compared to VMware. So again, you have the processor. In some of these, you can only change them if the system's not powered on. The virtual machine can't be running to get in this, but you can definitely change the network attachment. This is with the SCSI controller with the fiber channel for the network, the virtual SAN. So if it's configured, you can drop down and get it. Otherwise, the network adapter will be connected to whatever it's named there. All right. The virtual hard disk can be 3 different flavors, either a fixed size, which means all of the hard drive space is allocated at once, or it can be dynamically expanding, which means it will grow as it up to the maximum size, or it can be a differencing disk. And we're going to talk about differencing disks next week and use those. And that's how we're going to do the parent-child relationship between the parent system and the parent's hard drive and the child's hard drive. Okay. The differencing uses the parent-child relationship. All right. Now, virtual disk can be created when a VM is created, or you can use the new virtual disk wizard. And with the wizard, you can either compact a drive, convert a drive, expand a drive, merge a combined drive, or reconnect to another hard drive. All right. So here's the virtual disk wizard. And you can choose the action and go from there. Hopefully, we won't have to do this on any of your hard drives. If we were using snapshots and differencing disks, we would have problems with this, but we're going to try to stay away from that to eliminate some of these problems. All right. Pass-through disk is a physical disk attached to the host that's placed offline, so they can only be used by virtuals. So only the VMs can do it. And it has performance advantages over virtual disks, but it loses some of the flexibility. But the advantage is it can be larger than 2 terabytes. So if we're using VHD disks versus the VHDX, the maximum hard drive is 2 terabytes. So that's an MBR disk versus a GPT disk. All right. There's some quality of service stuff. I'm going to leave that for you to read here. You can look through that. Managing the virtual disk, we're going to use the Hyper-V Virtual Manager. And normally that's where we're going to go look at the hardware settings and then look at some of the resources. The BIOS can be allocated, looked at, memory, dynamic memory, smart paging, virtual processing. So all of those are in there. With the generation 1, we have the standard BIOS. Generation 2 is firmware instead of BIOS, so you can enable secure boot if you need it. Memory allocation, server 2019 with Hyper-V needs about 800 megabytes of RAM plus 32 megabytes for each running VM. So if we have, that's not a lot of memory, but we definitely want to make sure we save some memory for the host machine. If we use all the memory in our VMs, our host machine's not going to have enough memory to operate properly. Okay, dynamic memory. This is a Hyper-V feature that allows an administrator to set startup, minimum, and maximum memory. Remember with the memory manager at 3.0, it has the startup, the minimum, and the maximum. And Hyper-V adjusts the memory allocated for a VM up or down based on its needs between the minimum and maximum value. It's not enabled by default. You have to enable by choosing it when you set up the VM, right? So here you can see the memory is configured here, and you gave it the startup, give it a gig, give it half a gig for the min, and then 4 gigs for the max, and use dynamic, and away you go. Okay, normally we're not going to change these settings. Once we set them up, they're by default, they're pretty good for what we're doing. All right. Smart paging is where you can actually use the host computer for temporary memory instead of the virtual machine using virtual memory. But that only works with dynamic memory. Processor settings, we're going to leave these by default. It does a good job, but you can see here on the processor, you can tell how many virtual processors, and then you can set some of these thresholds for that as well. And this will say the sockets that it has and so forth. Okay, some of the integration services, this is like the VMware tools or the VirtualBox tools if you've used VirtualBox. And this will give us an improved performance for the hard drives, the network, and the mouse and video. So it will give us, it upgrades the network interface from a 1 gig to a 10 gig connection. And then it will use some of these improved network and mouse and video. Okay, and these are, this is installed automatically. Once the VM's created, Microsoft Hyper-V will go ahead and install these. It also will give us some, gives us the ability to use the shutdown command. It will synchronize the time between the VM and the host machine, exchanges heartbeat or data and heartbeat, and it will install the VSS, the volume shadow copy service that allows it for the backups and turns on the guest services. Okay, we can set up our VMs to automatically start and stop when the host machine turns on. We're not going to do this in this class because we're going to manually manage those, but you can set them to do that. Checkpoints, again, we're not going to use checkpoints because we're going to use differencing disks, and differencing disks and checkpoints don't play nice together. So let's skip over this. Resource metering, if you need to kind of keep an eye on what the CPU usage is, what some of the network traffic is, what the memory, what the hard drive, you can do that within Hyper-V. You can also do it from within PowerShell. So here's where it shows the PowerShell doing the resource pool. Enhanced session mode. This is a feature that improves interaction and device redirection between the host computer and the VM. It allows you to, probably the one that's most important for us is the copy and paste of data files and folders. So if we need to copy something from our host machine to the enhanced session will allow that. To use enhanced session mode, you must enable it in Hyper-V and on the guest operating system. And then you can verify that they're running. And that's a brief overview of Hyper-V, okay? And the install of a virtual machine. So I'm gonna do that. Now, in today's lab, on our host machine, we need to do a couple of things. So I'm gonna stop this recording.